All right, this is 18 from 2.1. We have a function y equals 2x squared minus 13x plus 5. We want to find its derivative and then the equation of the tangent line at x equals 3. So let's begin with the derivative. We'll use the definition of derivative, the limit definition. The limit is h goes to 0 of f of x plus h minus f of x all over h. So in application here to our function, we plug in x plus h everywhere there is an x, and we will have 2 times x plus h squared minus 13 times x plus h plus 5, and we're going to subtract the whole entire function, which is 2x squared minus 13x plus 5. That's all over h. All right, we want to get to some expansion now. So we have the limit as h goes to 0 of 2 times x plus h quantity squared is x squared plus 2xh plus h squared. We'll distribute the 13. We'll have minus 13x minus 13h plus our 5. We'll distribute the negative. We'll have minus 2x squared plus 13x minus 5. That's still all over h. Let's see if we can put anything together as like terms. I notice there is a minus 13x and a plus 13x. Those make 0. There is a plus 5 and a minus 5. Those make 0. I can see mentally this is a 2x squared, and here's a negative 2x squared. So that term is going to be 0 as well. So let's see what we have now. A limit as h goes to 0 of, well, this will be 4xh. This will be 2h squared. And we also have a minus 13h left over to the right. That's all over h. All 3 remaining terms in the numerator have an h in them. Let's factor that out. So this is the limit as h goes to 0 still of h over 4x plus 2h minus 13 over an h. That h is, of course, going to cancel as a common factor in numerator and denominator. Leaves us with the limit as h goes to 0 of 4x plus 2h minus 13. Now, as h goes to 0, that middle term is also going to approach 0. So we're left with 4x minus 13. That's our derivative, dy dx. So there's the answer to part A. For part B, we want the equation of the tangent line at x equals 3. So we need 2 things to write the equation of any line. We need a point and we need a slope. So we have an idea of how to get the slope. That's going to be using the derivative. We have half of a point at x equals 3. We need the y value of that point. So let's do that part first. Let's come back to the function and plug in a 3. So y of 3 is 2 times 3 squared minus 13 times 3 plus a 5. So that's going to be, well, 2 times 9 is 18. 18 minus, let's see, what, 39? And then, let's see, plus a 5. So 2 times 9 minus 13 times 3 minus 39 plus a 5. And then that's 18 minus 39 plus a 5. And I'm coming up with negative 16 here as my y value. So that's a point of 3 comma negative 16. Then for the slope, we want to look back at dy dx, and let's go dy dx evaluated at x equals 3. So that's going to give us a 4 times 3 minus 13, or 12 minus 13 for a slope of negative 1. And that means I have everything I need now to write the equation of the line. It's going to be y equals our slope, negative 1, times x minus the x value, there 3 of the point, and then minus the 16 y value. So there we have it, the equation of the tangent line, that's here. And then we have the derivative of that function, that's there. Hope this helped with your work.